So far, we've been looking at the master, how it operates, how it does a transmit, how it does a receive. Now let's look at it from a slave point of view. So let's say the Arduino is actually acting as a slave in the I2C communication. So slave, remember, has to wait for a transmission. It can't initiate anything. It has to sit there and wait. Now, waiting is conceivably a problem because how does the machine wait? One way is to use what's called a busy wait loop. Now, a busy wait loop is immensely wasteful. Basically, it's just a while loop. And a while loop that's just infinitely checking to see if a request has been received. Now, the reason why this is wasteful is because the slave can't do anything until the request is received. So let's say it runs for an hour before a request is received. For that hour, it's just sitting there in a wait loop, while loop, doing nothing. So they call it busy waiting. That's a waste. So we don't want to do that. We would like the Arduino or the microcontroller in general to be doing things, useful things, and then every once in a while, maybe a request is made, and it has to wake up and then handle that request. Maybe the write transaction, so it needs to read whatever receive the data, but then it goes back to what it was doing. So we want this processor to be continuing this normal operation and just be basically interrupted periodically when it has to deal with I2C. So what we use for that are called callback functions, and this is a general thing used not just in this domain but in lots of different domains. A callback function is a function that is called when an event occurs. So while the event is not occurring, the processor can be doing whatever it's doing, right? The Arduino can be running whatever code, but every once in a while the interesting event will happen. In our case, write request is received or something like that, write transmission, I2C. When that event happens, a callback function is invoked. So that callback function is executed and then it can go back to what it was doing. So we're going to use callback functions for both types of transmissions. So for instance, we've got wire.onReceive. Wire.onReceive is a function that identifies the function called when the slave receives data from a master. So if the master initiates a write transaction, then the slave is going to have to receive data. So when that happens, when the master initiates a write transaction, a callback function is called on the slave. And this function onReceive, wire.onReceive, it names the function that is going to be called when data is being received by the slave. Now, then we've also got this wire.onRequest, and this names the function that is called when the slave receives a read request. So if it receives a request like that, then the function that's going to be named in the onRequest is called. Now, note that onReceive and onRequest are not themselves the functions that handle the receiving and the requesting, right? The servicing of the request. They're not the functions. They just provide the names of those functions. So let's watch. Okay, so let's take a look at some slave code. Now, in this slave code, actually go straight to the bottom. Wire.onReceive receive funct. So what that says is, look, when this slave receives gets a write request from the master, right? When the master says, I'm doing a write transaction, that means the slave has to be ready to receive that transaction, right? So when that happens, the function called receive funct, which is the argument to wire.onReceive, that function is going to be called to do the receiving of the data. Now then above it, right at the top, you can see the definition of that function, receive funct. And see what it does. Skip the argument for a second. It's a for loop. Inside it just calls wire read, right? So it reads the data, which is presumably the data coming in from the master, and it's adding it to this sum. Is computing a sum, and then at the end of the loop it just says serial.print sum. It prints the sum. So that's all this thing is supposed to do. So when this slave gets it sees a write request from the master, all it does is it takes all the data that's being written, it adds it up into this sum, and then prints it on its serial output. Okay. So and note that this receive funct, it takes one argument. Okay, an int byte num. That argument is an integer. That is the number of bytes that are received. So when you write this function, that function receive funct, it can have whatever name you want, okay? But that function has to take one argument, which is the number of data bytes that have been received. And then you can see how inside the function it's using that byte num in the for loop. It's saying I equals 0 to I is less than byte num because it wants to call read once for every byte that's received. So this callback, so receive function is called a callback function. And you call wire.onReceive, you pass it an argument, which is the name of the callback function which you've defined. And the name can be anything you want. In this case, I call it receive func, since that's a reasonable sounding name. Now, for transmission, so let's say the slave, instead of responding to, instead of receiving a write transaction request from the master, it gets a read. Okay? Now, if it gets a read, that means that the slave now has to do the transmission, right? Because the master is saying, look, give me this data. It's requesting data. So the slave has to do the transmission. So again, at the bottom, you can see write.onRequest transmit funct. So wire.onRequest transmit funct. So transmit funct is going to be the name of the function that's going to do this transmission. So on request, since we're passing that name as an argument to the on request function, that ties it to the request event. So when the event happens that the slave receives this read request, then it calls transmit funct. And if you look at transmit funct at the top, all that does is it just calls write. It sends some data. Okay, it sends a byte. Very simple. It could do whatever we want. In this case, it just sends one byte. And this transmission function, this callback function called transmit funct, it has to take no arguments and returns nothing, returns void, and it should take no arguments. But its name can be whatever you want it to be.